Hello, my name is Fernando Polito, and I'm the Truck Product Manager here at Horton. Today we're going to be talking about our latest introduction into the product arena with our E-Fans. So what you see in front of me here, or to the side, is a potential configuration that we are using as we're rolling out these new products. So here we're looking at an array that consists of two motors with integrated inverters. The yellow connector here is for the high voltage. The lower connector that you see here is for the low voltage. And because of the heat dissipation that's required and the power density that is required, we actually have to deploy liquid cooling, and there you can see the hoses that represent that. The rest of the system is complemented by finger guards and the individual fans at 445 millimeters diameter. Now, we have that flexibility, depending on the customer arrangement, to go with one single larger fan that can go as high into the 700 millimeter range with a much larger fan and inverter. But again, we have that flexibility also with this particular arrangement where we can have it without the inverter integrated with the motor. Now, this is an introduction for us into this arena, and we are thinking that this will help us deploy a very efficient system. The power draw on the motors is 2.5 kilowatts. The airflow is 1.8 cubic meter per second. The tight compact design allows for easy integration into tight spacing where we find that we have a limited actual availability of spacing or dimension. The 5.1 E-Fan array was designed for a battery electrical vehicle, or BEV, and or a hydrogen fuel cell truck. So in addition to the traditional fossil fuel truck configurations that consisted of heat exchangers or radiators with coolants and ram air coming into the front grille of the truck, the E-Fan system of the future will also need to be serviced with cooling circuits. Depending on the configuration used or concept used by the OEM, it may take the form of several heat exchangers or one single heat exchanger with different regions that need to be cooled. A key difference will be the delta temperature that we need to moderate or control between what's coming out of the radiator, the power electronics, and the thermal management of the batteries versus the temperature coming out of the radiator and the diesel engine. So the liquid cooling is applied due to the high power density of our system. High temperatures reduce the lifetime of the lithium-ion batteries, and even higher temperatures increase the possibility of thermal runaway. The liquid cooling that you can see here on our E-Fan system was designed, as we said, for the higher power density, which leads to a protection during charging of the system, and also during the usage of specific duty cycles that could lead to degradation of the batteries and thereby increases the lifetime of the system. So this concludes our video for the 5.1 E-Fan. Thanks for watching.